In the previous tutorial, we learned how to create objects and store references to the objects in variables. In this example, the statement creates a text object and stores a reference to that object in the text variable intro. Once we have a reference to an object, we can manipulate that object using methods. We introduced methods in a previous tutorial using the string type. Recall that methods allow you to apply built-in functionality to particular data. To call a method using a variable, use a period after the variable name, then the name of the method followed by any arguments. Here we use the append string method to add some text to the end of a string contained in the variable s. The type text also has associated methods. For example, the setCaption method is used to change the string that will appear in the graphic. In the case of string variables, methods are applied to the strings contained in the variables. In the case of text, the variable does not contain a text object, but rather a reference to a text object. However, since presentation knows that text is a reference type, the method will be applied to the object referenced by the variable. We can use another text method, caption, to see that the setCaption method actually had an effect on the text object. An important distinction is that the setCaption method is an example of a method that changes an object. In contrast, the caption method is an example of a method that returns information about an object. A reference type method is applied to the object referenced by a variable. You might wonder what happens if you call a method using a reference variable that doesn't actually reference any existing object, one that contains the null reference value. You can find out by running this example in which the text variable intro is not initialized with a reference to an object. When presentation attempts to call the setCaption method, it will have no object to use because intro contains the null reference value. At that point, the program will stop running and presentation will report an error. We can see all the things we can do to a text object on the text type reference page in the presentation documentation. At the top is a list of properties. You can think of a property as something that describes an object. Each property has a type that indicates what type of data it is. Here we see that caption is a string property and can read a description of what it represents. In presentation, properties are changed or retrieved only using methods. The list of methods appears below, where we see the method we used, caption, and setCaption. You can think of properties as representing what's stored inside the object. However, exactly how it's stored or what additional data might be stored is not important. It's important not to think of objects as simple collection of strings or ints that make up its properties. Rather, you should think of an object as a kind of locked container into which you cannot see. The objects combined with the methods provided by its type handle everything for you. You only interact with the object using the interface provided by the type's methods. We can illustrate this concept further by finally explaining the statement we have been using to print information to the terminal box. In the documentation, we see that there is another reference type named terminal. Objects of type terminal represent a box in the user interface to which we can print. Presentation only provides one such box for you, and that box is always available. For this reason, it is not possible for you to create an object of type terminal like we did for type text. Instead, before your program starts, presentation creates a terminal object for you which is associated with the terminal box in presentation. In order to access this object, presentation also automatically creates a terminal variable named term and initializes it to reference the terminal object. Thus, before your program starts, presentation has already set up for you the situation illustrated here. This is called a predefined variable, and you can see term listed at the top of the terminal reference page. We can also see listed the print line method, which has different versions for printing different types of data. So when we were printing to the terminal, we were using a method call on a predefined variable of type terminal. This relates to how we should think about objects because For the type terminal, we have absolutely no idea what data might be stored in the object or how its methods manage to print things to the box in the user interface. All we need to know is what the type represents and what its methods do. Going back to the type text, we can now demonstrate the point made in the previous tutorial that variables of reference types do not contain objects, but rather references to objects. Let's create another text variable, intro2, and assign the value of intro to it. Then we will change the caption using the variable intro, but print the caption property using the variable intro2. Since something else is printed, this demonstrates that both intro and intro2 reference the same text object. If the assignment to intro2 had made a new copy of the object, then changing something using intro would not have affected intro2. By contrast, if we create another string variable, s2, initialized with the value of s1, and then change the string in s1, this does not affect the string in s2. We can see this because only hello is printed to the terminal, and not hello there, as would be the case if s2 was a reference to the string s.